So, to begin this assignment, the Balancing Chemical Equations or Virtual Balancing Equations assignment, click on the introduction. First off, we are exploring the parts of the chemical equation. Note that reactants are on the left side and products are on the right side of the arrow. If there is more than one reactant or more than one product, they are separated by plus signs. You never change the chemical formula of any of your reactants or products when balancing. The only thing you can change are numbers in front we call coefficients. As you add a number in front of each of these compounds, you see little molecules pop up in the white space. What you should note is that as you put a 1 in front of the N2, two blue dots came up, indicating that each blue circle is a nitrogen. And as you put a 1 in front of the H2, two white circles appeared, indicating each white circle is a hydrogen. In balancing equations, the atoms that are on the left side are the atoms that are on the right side. They're just rearranged. Thus, if you had this many things react on the left side, you should have an equal amount react and rearrange on the right side. Make it so that each thing is balanced, or rather that both your nitrogen and hydrogen atoms are balanced on each side of the arrow. So first we'll start with balancing nitrogen. You have to increase the right side because there's not enough nitrogen. That increases your hydrogen, so on the left side you need to then increase your hydrogen until it is balanced. For the first phase, you are now balanced if you have changed your coefficients so they are 1, 3, 2. There are a couple things to note, common problems that occur with balancing. If you, like for example in this one, if you have something that's balanced on one side, like hydrogen, it can be daunting to change something that will make it so that hydrogen is no longer balanced. But when one thing is not balanced or cannot balance, this is an indication that we will probably have to make multiple changes to make it actually balance. In the case of H2O being a reactant and H2 and O2 being your products, your oxygen is not balanced on the left side. As we increase the H2O, it increases the oxygen and balances it, while making the hydrogen not balanced. This is an easy fix. All we have to do is then rebalance our hydrogen by increasing the H2 or the hydrogen on the right side. Our final example is combusting methane. It's our most complicated example where we have carbon, hydrogen, and oxygen. Anytime you have multiple elements to balance, you're going to want to make a list of them, and you should probably keep track of how many are on each side. This list, as you balance, you'll go down your list balancing them one at a time. If something becomes unbalanced, start at the beginning and balance again. So let's go ahead. We're going to go carbon, hydrogen, oxygen. One of the reasons why we're doing oxygen last is because your products have oxygen in them, both of the products, not just one of them. Start off with one of everything and start off with carbon. Looking at carbon, we have one carbon, that's the gray circle on the left, and one gray circle on the right. It is balanced. Next, we balance hydrogen. On the left side, we have 4 white circles for hydrogen. On the right, we have 2 white circles or 2 hydrogen. We have to increase the thing with the hydrogen until we have 4 hydrogen total or 4 white circles. Currently, our carbon and hydrogen are both balanced. Our next step is to balance the final element, oxygen. On the right side, there is 4, and on the left side, there is 2. We have to increase the molecule that has oxygen until it is balanced. Now, with equal numbers of oxygen, carbon, and hydrogen, we have balanced this equation with coefficients of 1, 2, 1, 2. This is just our precursor, or basically our intro into this for the game. You're going to go into the game and you're going to complete each level. Start off by putting one of each thing. Differences in the game that you might notice right off the bat is that, well, there's no balance automatically. It doesn't also tell you what element is what in terms of your molecule that's being made. You need to go in there and you have to count each, of course, colored circle. In this case, there's one gray circle, two red circles. So you should deduce that carbon is the gray circle and that since there's O2 in this molecule, the two red circles are oxygen. Next, with identifying the type of element per color of circle, go in and try to balance it out. Right off the bat, you should pick balancing one of the elements. I'm going to start with carbon. Your gray circle on the left and gray circle on the right are even. Next, you should go on to your next element, which is oxygen, red circles. 2 red circles on the left, 3 red circles on the right. Here's one of the common problems that we do hit. If you have an odd number on one side and your left side, that element can only be even. Increase your substance that is even and try then to make your right side become even as well. Now you wouldn't increase your O2 because that's only going to increase it by 2s. The 1 here that's an odd number is what's making your overall oxygen be odd. Increasing this will increase the oxygen so that it is at 4, just like the left side. Also, 2 carbon, turns out that that actually did balance out our issue with oxygen and it balanced out our carbon, so we'll click check. If you get a question correct, you'll get 2 points. But if you make a mistake and check, it'll tell you that it's not balanced. You can click show why, or you can click try again and attempt at least one more time. If you can't get it this next time we try it, then you'll probably have to redo the level since you won't get any of the points for that question. You must receive a 9 out of 10 to receive credit for the level.